Have you ever just stopped and wondered about what reality is really made of? You know, we usually picture particles as these tiny little things floating around in empty space. But what if that whole picture is kind of wrong? What if there's a way to look at the universe that makes one of the weirdest quantum puzzles feel, well, surprisingly simple? Let's explore that idea based on one really cool philosophical model. Okay, right off the bat, let's just throw a huge wrench into how we see things. Forget the idea of a big, empty void. I want you to imagine that space itself is the fundamental stuff of the universe, like a single cosmic fabric that's always moving, always active. If you can make that one little shift in your head, everything else starts to look different. So let's pull on that thread, shall we? Let's see what it really means to live inside a wrinkle in reality. Here it is, the big analogy. Instead of a universe filled with a bunch of separate objects, just picture one unified field, one fabric. And all the things we call particles, an electron, a quark, they aren't separate things at all. They're just localized, persistent wrinkles in this all-encompassing fabric. They're literally made of space. Now you might be thinking, okay, cool idea, but why do we need it? Well, it's because this new way of looking at things might just help us solve a famously tricky problem in physics, the whole randomness of particle decay. See, in the standard way of thinking, it's basically impossible to predict when any single particle will decay. It's a total game of probability, like rolling a cosmic die. Physicists are great at telling you when, say, half a group of particles will decay. But for any one specific particle, it's a complete mystery. And that's where this idea of half-life comes from. It's an amazing tool for making predictions about huge numbers of particles, but you gotta remember, it's all based on statistics. It describes the odds, not the cause. It tells us what's gonna happen to the group, but it has absolutely nothing to say about why it happens to that one particle at that one specific moment. And this is the crucial point, right here, in this quote. Why do we have to rely on statistics in the first place? Well, this model suggests it's because our knowledge is incomplete. It's not that reality itself is random, it's just that we can't see the whole picture. It's a fascinating little seed of doubt, isn't it? So, that brings us to the alternative. Let's really dig into this fabric of space idea and see how it builds a totally different picture of reality. In this view, space is no longer the passive background, the stage where the play happens. No, space is the play. It's the main actor. The universe is just changing space, interacting with itself. The stage and the actors are exactly the same thing. There's only the fabric. So let's break down the ground rules here. First, the absolute foundation of everything is this single active fabric of space. Got it? Second, the things we call particles are just these persistent little wrinkles in it. And third, and this is the part that'll really bend your brain, particles aren't in space, they are space. Just a very structured, localized little piece of it. Okay, so if reality is just one big, wobbly fabric, how does anything actually happen? How do these wrinkles change or, decay? The answer is action. This fabric isn't sitting still. It's buzzing with activity. It's filled with waves of all sizes. You can think of these as the constant hum of the universe, little ripples of energy that are always zipping through the fabric, carrying information and bumping into things. And this gives us a really simple, logical chain of events. A wave, or maybe a whole bunch of them, is traveling along. It runs into one of our wrinkles. That moment of interference, that collision, is everything. The nature of that interaction determines the particle's fate. It's totally physical, and if you could see it all happening, it would even be predictable. And it all boils down to two super simple outcomes. If a passing wave just kind of nudges the wrinkle and leaves its structure pretty much alone, then the particle stays stable, no big deal. But if that wave hits it in just the right way to totally change its fundamental structure, well, that's decay. That's the moment it transforms. So let's bring this all the way back to our original puzzle. What does this whole new picture actually mean for the idea of randomness? And we come right back to this killer quote. See, decay only looks random to us because there's no way we could ever track every single tiny wave rippling through the entire fabric of the universe. We can't predict when one is going to hit a specific wrinkle with just enough oomph to change it. The system has a cause, but it is so incredibly complex that we could never measure it all. This just makes the whole philosophical shift crystal clear. The standard view says randomness is a real feature of the universe. That's an ontological truth. It's just baked into how things are. But this fabric view says, no, randomness is just a label we use for the limits of our own knowledge.
That's an epistemological limit. In other words, we use probabilities simply because we're ignorant of all the hidden causes.
And that, right there, is the huge takeaway. We move away from thinking about a universe full of things to a universe that is one single, unified process. The universe isn't a collection of objects anymore. It's a single, dynamic thing whose constant changes create the world we see. And that leaves us with one last mind-bending question to chew on. If the most fundamental building blocks of matter are just patterns in a single medium, what else that we see as a separate thing, a chair, a planet, even you, is really just a temporary, complex wrinkle in the fabric of reality?